The origins of space-time. As Earthlings, we take space for granted. From our vantage point, it's a zone roughly 100 kilometers above the globe with no air to breathe or scatter light. Isn't it just emptiness after that? Time also passes inexorably. That is not the case. Over the last century, physicists have discovered that space and time create a system of such amazing complexity that it may challenge our knowledge of reality. So in this video, we'll look at what makes up space-time. Hello and welcome to Zeey. Subscribe to our channel and ring the bell to receive our daily videos. Space is enormous, and we know very little about the qualities of space-time itself. We know it warps and curves, but what precisely makes it up? Only 5% of the universe is made up of baryonic particles, according to astronomers. The remaining 95% is made up of dark matter and dark energy. Apart from watching their impacts, we currently know little about them. We perceive space to be empty, although this is not the reality. The diameter of the observable universe is 46.5 billion light-years. Our universe is 13.8 billion light-years old. We know all of this by observing all of the light emitted by distant galaxies all the way back to the Big Bang. The cosmic microwave background radiation is the afterglow of the Big Bang, and it reveals information about the early cosmos. Furthermore, while space is a vacuum, it is not empty. Gas, interstellar dust, and other pieces of stuff float around in the emptier portions of our cosmos, while planets, stars, and galaxies live in the more congested regions. We cannot, however, be certain that our universe is the only one that exists. We have no idea what exists beyond the visible universe. But what exactly is dark energy? What is this enigmatic force that accounts for around 68% of our universe? Scientists believed in the early 20th century that the universe's expansion had to slow down over time. They reasoned that the energy density would drop and gravity would take over, forcing the expansion to slow down. Just like when you throw a ball in the air and it falls back down after a while. However, when Hubble pointed his telescopes to the sky in 1929, he noticed that distant galaxies were drifting apart. He then stated the well-known Hubble law. Every distant galaxy, according to it, is traveling away from each other at a rate proportional to its distance. The greater the velocity with which a galaxy goes away, the further distant it is. Everyone was perplexed by this concept. It's like throwing a ball into the air, and instead of slowing down and returning to Earth, it keeps speeding up and going away from us, finally in space and away. If we see something like this with the ball, we conclude there's an invisible force at work. Dark energy was found by three scientists, Adam Rees, Saul Perlmutter, and Australian astronomer Brian Schmidt, who won the Nobel Prize in 2011 for their finding. It is the most significant scientific discovery in history. The discovery of dark energy and the fact that it is driving the cosmos to expand at a quicker rate astounded physicists. We calculated the rate of acceleration by mapping the cosmic background radiation left over from the Big Bang using the Planck telescope. The Planck mission's final results, released last month, reaffirms that dark matter and dark energy must exist, even if we don't know what they are. Everything but our nearest neighboring galaxies will be out of reach in a few hundreds of billions of years. No matter how fast future humans travel, we'll never be able to reach anything else. More is unknown about dark energy than is known. We know how much dark energy exists because we understand how it influences the expansion of the universe. Aside from that, it's a complete mystery. One theory is that dark energy is a property of space. Albert Einstein was the first to recognize that empty space is not insignificant. Space contains incredible qualities, many of which are only now being discovered. People believe that space is perhaps limitless. But what exactly is in this space? Apart from planets, stars, comets, asteroids, dust, black holes, and a few other objects, practically everything in the universe is made of hydrogen. Hydrogen is the lightest element and is found everywhere. It can be found in places ranging from hot, dense star nurseries to frigid, vast spaces between galaxies. According to Harlan Ellison, the two most common things in the universe are hydrogen and stupidity. The most prevalent element in our universe is hydrogen. But what about the interatomic gap between hydrogen atoms? What constitutes a vacuum of space? This is where I would have to invoke quantum mechanics, and things get very strange. I think I can safely say that nobody understands quantum mechanics, said Richard Feynman, and he was right. The universe appears to have a minimum resolution on the tiniest scales, which is known as the Planck length. On these scales, the universe appears to be a bizarre quantum foam, with virtual particles appearing and disappearing according to quantum physics. Despite how contradictory it may appear, we can really test the effects of quantum physics in the laboratory, such as the Casimir effect. Classical physics could tell you that if you lay two very thin plates just nanometers apart in a vacuum, the space between them is empty. However, the boundary of the plates has an effect on the sea of virtual particles predicted by quantum physics. Fewer virtual particles can be formed in this narrow constrained zone than on the outside of the plates. This vacuum energy could be the key to understanding the universe's dark energy on the biggest scales. Quantum mechanics is our most comprehensive and in-depth knowledge of reality. However, a challenge comes when attempting to comprehend quantum mechanics. Sincere physicists admit that we do not fully comprehend quantum mechanics. We have a recipe that we learned in school, but we have no idea what's going on behind the scenes. However, the wonders of quantum mechanics are for another video. That was everything about space and what makes it up. What exactly is space-time? Space and time are like two sides of the same coin. When he combined these concepts in the theory of relativity, the famed physicist Albert Einstein invented the concept of space-time. We are all familiar with the three dimensions of our three-dimensional world: length, width, and time. Einstein connected it to the fourth dimension, time. We can remain at rest in space, such as a man sitting on his chair. But time always moves in one direction, it never stops. Space-time, according to our current understanding of physics, explains the strange relativistic events that result from traveling near the speed of light and the motion of huge objects in our universe. Newton's rules explained the motion of large things before Einstein connected space and time, while Maxwell's equations detailed the qualities of light. But by the end of the 19th century, every physicist had noticed something peculiar about light. Experiments revealed that the speed of light was always constant regardless of the reference frame from which it was observed. Poincaré, a French physicist, theorized at the same time that the velocity of light might represent an unbreakable limit. Finally, Einstein combined all of these theories in his 1905 theory of special relativity, which proposed that the speed of light was constant. To be true, space and time had to be united in a single framework that conspired to maintain the same velocity of light for all observers. Einstein, on the other hand, did not reach the same conclusion. In 1908, German mathematician Hermann Minkowski stated, "Henceforth space by itself and time by itself are doomed to fade away into mere shadows, and only a kind of union of the two will preserve an independent reality." His spacetime is known as the Minkowski spacetime, and it serves as the backdrop for computations in both quantum field theory and relativity. But how does spacetime function? When people talk about spacetime nowadays, they often characterize it as a sheet of rubber or, more commonly, a cloth. This is attributed to Einstein, who realized while developing his general theory of relativity that gravity was caused by warps and bends in the fabric of spacetime. Massive objects, such as the Sun and Earth, induce distortions in spacetime, causing it to bend. Because objects must follow the path along the curved spacetime's curvature, these bends or curves restrict how everything moves in the cosmos. Gravitational motion is actually motion along the curved spacetime. In 2011, NASA launched a spacecraft called Gravity Probe B, which examined the form of the space-time vortex surrounding the Earth and discovered that it closely matches Einstein's prediction. However, most of it is still difficult for people to comprehend. Though we can compare space-time to a sheet of rubber, the comparison eventually breaks out. This is due to the fact that the rubber sheet is two-dimensional, whereas space-time is four-dimensional. The warp extends not just in space, but also in time. Despite its complexities, relativity is the best explanation for the physical phenomena we witness. However, a problem has been hanging over the horizon for physicists for the past 100 years. As previously noted, the difficulty is to unite general relativity with quantum mechanics, which explains the properties of subatomic particles with high precision but excludes gravity. Some theorists believe that spacetime is composed of quantized chunks. Some people are attempting to quantify gravity. When people used to talk about quantum gravity, they meant quantum discreteness, quantum fluctuations, and practically every other quantum phenomena in the book. We hope that our scientists will be able to solve this challenge in the future. But there is one thing that all scientists agree on: empty space is shockingly complicated. What are your thoughts on spacetime? Could you visualize it? Please share your ideas and questions in the space below, and remember to like the video, subscribe to our channel, and click the bell symbol to be notified of future outstanding videos like this one. Thank you for your time.